speak about the two forces, that is cohesive force and adhesive force. We'll have to speak about the two forces associated with liquids, that is cohesive force and adhesive force. Before speaking about cohesive force and adhesive force, let's have two vessels. We are having one vessel like this, and there is our next vessel like this. These are the two vessels into which we are filling some fluid. You're filling some sort of fluid into the two vessels. If we are filling one type of fluid into one vessel, the fluid is lying like this. The fluid is lying like this. And if we are filling another type of fluid into that same type vessel, let's say it's glass vessel, in the two vessels are glass vessels, then the fluid is lying like this. One of them is mercury and one of them is water. Can you say which is mercury and which is water? There is two glass vessels over to which one we are filling it with mercury and other one it is filled with water. Which is mercury and which is water? What's your opinion?
First one water.
First one.
Second one mercury.
Second one mercury.
First one is water, second one is mercury. Why are you saying first one is water? We have seen water sticking on the glass, isn't it? Water will be raised near the glass. You are correct. The first one is water and second one is mercury. Water is making a concave meniscus while mercury is making a convex meniscus. Mercury is making a convex meniscus. Okay. Then what happens over here is there is a force between similar molecules and there is a force between dissimilar molecules acting over liquid and surface. The force of attraction between the similar molecules in liquid, it is called as cohesive force. The force between similar molecules is called as cohesive force, and the force of attraction between dissimilar molecules, it is called as adhesive force. Adhesive force. What's cohesive force? The force of attraction between similar molecules, it is called as cohesive force. The force of attraction between dissimilar molecules, it is called as adhesive force, isn't it? Therefore, if I'm saying as an example, the force between water molecule and water molecule, the force between water molecule and water molecule, it is cohesive force. And the force between mercury and mercury, it's also cohesive force. But the force between water and glass and the force between mercury and glass, it is adhesive force. The force between dissimilar molecules is adhesive force and the force between similar molecules is cohesive force. Fine. I'm not sure about the spelling. I cannot say the spelling of any of the terms which I am mentioning. It is there in your text. You can refer. Okay. If I'm saying it as, or if I'm spelling it wrong, it would be a difficulty for all of you. Therefore, there are two forces, cohesive forces and adhesive forces. Adhesive forces. Then the force between similar molecules is cohesive force, as I've mentioned. Over here, which is greater? If we are looking at the situation, water in a glass vessel, is cohesive force greater than adhesive force, or adhesive force greater than cohesive force?
Adhesive force is greater than cohesive force.
Yes, the force between glass and water is greater than the force between water and water. That's the reason why, or you could say cohesive force is less than the adhesive force. That's the reason why water is sticking towards the glass and it is making a concave meniscus. Okay, the opposite is the situation over here. In this situation, in the second situation, in the next situation, what we can say is the force of attraction between mercury and mercury is greater than the force of attraction between the mercury and glass. Therefore, the adhesive force is less than the cohesive force, or the cohesive force is greater over here. In the mercury and glass situation, cohesive force is greater than the adhesive force. Adhesive force is lesser than the cohesive force. That's the reason why the mercury is trying to avoid the glass. That's the reason why it is making a convex meniscus. Is that clear? What's cohesive force? Is it force between similar molecules or dissimilar molecules?
Similar molecules.
Similar molecules.
And the force between dissimilar molecules is adhesive force. Okay. Therefore, now we know what's cohesive force and adhesive force. Then we have to understand an angle which is called as angle of contact. If I have to speak about angle of contact, let's say, can you see this particular point? This is the point of contact between the water and the glass. This is the point of contact between the water and glass. And let me just draw a tangent from the point of contact between the water and glass. This is a tangent drawn from the point of contact between the water and glass. Then this tangent will make an angle theta with the vessel under the liquid. This tangent, it will make an angle theta with the vessel under the liquid, and this angle, it is called as angle of contact. Angle of contact is the angle made by the tangent drawn from the point of contact of the liquid and the vessel to the vessel under the liquid. Angle of contact is the angle made by the tangent drawn from the point of contact of the liquid and vessel to the vessel under the liquid. Is that clear? Is that clear, students? Angle of contact is the angle made by the tangent drawn from the point of contact. Angle made by the tangent drawn from the point of contact of the vessel and liquid to the vessel under the liquid. Okay. Yeah, if we are drawing it for mercury, we could consider this is the point of contact, this is the point of contact, and you will have to draw a tangent from the point of contact. In this situation, the tangent drawn, it should be like this. Therefore, this is the tangent drawn from the point of contact of the liquid and the vessel. Then this tangent should make an angle with the vessel under the liquid. Did I say vessel under the liquid? Therefore, this is the angle of contact for the mercury. Which is obtuse angle, which is acute angle?
Second one.
Second one is an obtuse angle. Obtuse angle is greater than 90 degree. First one is an acute angle. Therefore, for glass and water situation, the angle is an acute angle, and for mercury and glass situation, the angle is an obtuse angle. Am I correct? Am I correct?
Sir.
Yes. Therefore, this is regarding angle of contact. This is regarding angle of contact. For cohesive force greater than adhesive force, angle of contact, will it be less than 90 degree or greater than 90 degree? Cohesive force is greater than adhesive force. Angle of contact.
Less than 9.
If cohesive force is greater than adhesive force, angle of contact.
Obtuse
Greater than 90
Greater
degree.
than
Will be greater than 90. Cohesive force is greater than adhesive force. If adhesive force is greater than cohesive force, in that situation, the angle will be less than 90 degree. Okay. The vessel was made of glass. Did I say like that?
Yes.
Therefore, if I'm having a different situation, let's say we are having a silver vessel. Let's imagine that we are having a silver vessel over here. This is our silver vessel, and inside the silver vessel, if we are having water, the water will be lying like this. What is the angle of contact? This is water inside what? Silver vessel. Silver vessel. What's the angle of contact? And comment about the cohesive force and adhesive force. What do you understand about the angle of contact over here? And give me the description of cohesive force and adhesive force, which is greater and which is lesser. What's the angle of contact? You could comment the answer. You just comment the answer. What's the angle of contact? What's the angle of contact in the situation? Comment your answer quickly. And comment about the cohesive force and adhesive force, which is greater and which is lesser. Okay. Then in the situation, can you just say it unmuting your audio? What's the angle of contact?
less than 90.
What was the definition of angle of contact?
90
This was the
90
point of
degree.
contact.
90 degree.
Yes, let's try to understand it from the definition. This was the point of contact, and we will have to draw a tangent from the point of contact. Here is our tangent drawn from the point of contact. Am I correct? Since it's a plane surface, the tangent will be also in this direction. Then the tangent should make an angle with the vessel under the liquid. This is the angle that you have to consider. This angle is 90 degree. Did you understand now? If you are wrong, that's not a problem. You have tried. Okay. If you are wrong, and now if you have analyzed the situation, it will be in your memory. Okay. Those who have committed mistake, they will have more experience than those who have made it right in the first term itself. Okay. Experience is what matters. You should learn from your experience and you should grow from your experience. Okay. There is a situation where you are wrong. If you have understood you are wrong, you should correct it, and then onwards you should learn from that. Okay, then let's say angle is 90 degree. Did you understand the angle of contact is 90 degree? Then what about the cohesive force and adhesive force? In the situation, what we have to say is the cohesive force and adhesive force will be equal. Adhesive force and cohesive force, they should be equal, isn't it? Isn't it?
Yes, sir.
Yes, sir.
Yes. Therefore, now we are having the angle of contact, cohesive force, adhesive force situations and all. Now let's try to move further. If you're trying to move further, let's speak about the surface tension. What are we going to speak now? We're going to speak about surface tension. Okay. It's a phenomena experienced on the or exhibited by the molecules which are lying at the surface of a vessel. Let's imagine that we are having a vessel over here. This is our vessel that we are imagining, and let's say it is open at the top. It is having a fluid. We are not bothering about the surface or the contact point. We are just bothering, this is a very large vessel consisting of a lot of fluid inside it. Let's say we are imagining water inside it, and if we are imagining one molecule of the fluid over here, it will experience cohesive force. What's cohesive force? The force of attraction between
Similar
molecules. Therefore, what we can say over here is this molecule will be pulled in all direction by the similar molecules like this. It will be pulled in all direction by the similar molecules. Or if you are saying it is water molecule, it will be pulled in all direction by the water molecules which is around it. Therefore, the net force acting over this molecule will it be
Zero.
upward, downward, or zero?
0.
Zero.
Net force acting over this molecule is zero. Okay. Then if you are imagining a molecule which is on the surface of the fluid, let's imagine a molecule which is on the surface of the fluid. Then what happens is in this situation, the molecule will experience a force like this, and this is the situation for a molecule which is on the surface. What happens is, will there be a net force on this molecule which is on the surface? Yes or no? The molecule which is lying on the surface of the fluid will experience a net which force, upward force or downward force?
Downward
Yes,
force.
there will be a net downward force acting over the molecule which is lying on the surface of the liquid. Therefore, no molecule will have a wish to move towards the surface. സർഫസിന്റെ അടുത്തേക്ക് നീങ്ങാൻ ആർക്കും താല്പര്യം ഉണ്ടാവില്ല, കാരണം നെറ്റ് ഫോഴ്സ് സീറോ ആയിട്ട് നിൽക്കാനല്ല എല്ലാവർക്കും താല്പര്യം ഉണ്ടാവുക, ആണോ? Therefore, the molecules which are lying on the surface of the fluid will experience a net downward force, and it will try to move down, but it cannot move down since there is other molecules. This is an incompressible fluid. If we are having an incompressible fluid, all the molecules which are lying on the surface of the fluid will experience a net downward force. Thereby, the surface of the molecule, surface of the liquid, will behave like a tensed membrane. What happens is, the surface of the liquid will behave like a tensed membrane due to the net downward force acting over the molecules. Okay, that force per unit length, as I have mentioned, there is a net downward force acting over the fluid. The force per unit length acting over the fluid, or force per unit length acting over the surface of the fluid, it is called as surface tension. From the name surface tension, you might confuse that surface tension is actually tension and tension is force. നമ്മൾ പഠിച്ചിട്ടുണ്ട് ടെൻഷൻ എന്ന് പറയുന്നത് വയറിന്റെ മേലുള്ള ടെൻഷൻ എന്ന് പറയുന്നത് ഫോഴ്സ് അല്ലായിരുന്നോ?
Yes, sir.
Yes.
Therefore, you might confuse surface tension as force, but it's not force, it is actually force per unit length. What's the SI unit of surface tension? Is it Newton? What's the
No.
SI unit of surface tension? It's not Newton, it is
Newton
Newton
meter.
per liter.
per meter. Is it Newton per liter? No, it's Newton per meter. Newton meter raised to -1, isn't it? Newton meter raised to -1. Okay, then what's the dimensional formula? What was the dimensional formula of force? The dimensional formula of force was mLt raised to -2 divided by L. Therefore, mt raised to -2. Am I correct?
Yes.
Yes. Therefore, this is surface tension, the net force per unit length acting over the surface of the fluid is called as surface tension. The net force per unit length acting over the surface of the fluid is called as surface tension. This is molecular theory of surface tension. If they are asking you how is surface tension created, you could say a molecule which is lying at the midpoint of the fluid will experience no net force. The molecule which is lying at the midpoint of the fluid will experience no net force, since the forces will cancel out each other. But the molecule which is lying on the surface of the fluid will experience a net downward force that will make the surface of the molecule behave like a tensed membrane. That will make the surface of the molecule behave like a tensed membrane, and that is causing surface tension. Am I clear to you? Am I clear to you, students? Yes. Therefore, this is regarding surface tension, and now we are having surface tension. Then let's understand some common situations where we are having surface tension under acting. That is, have you or do you know swimming? How many of you know swimming? I think I have asked this previously. Raise your hands. How many of you know swimming? If you have been into the swimming pool or some pond and all, and you have tried different ways in which we are jumping over to the pool, sometimes and all, what happens is you will just fall flat into the water. We are just falling flat into the water. We used to say it like this: പൊറടിച്ചു വീഴാന്നൊക്കെ പറയും. മറിഞ്ഞൊക്കെ ചാടുമ്പോഴേക്കും ചില ടൈമിലൊക്കെ നമ്മളുടെ ആ ഒരു പരിപാടി കറക്റ്റ് ആയിട്ട് വർക്ക് ചെയ്യാതെ പൊറടിച്ചൊക്കെ വീഴും. It will be very much painful. Have you experienced it? If you're falling flat over to the water, it will be a painful experience. What happens is the surface tension will play. The surface of the water is behaving like a tensed membrane, and if you are falling flat over to the water, what happens is, due to the surface tension, there will be a large reaction force which is causing a severe pain. Okay, but if you're just scooping over to the water, what happens is you are in contact with a very small surface. Therefore, due to the high pressure, you will just move into. Okay, then as the next example, have you seen a leaf? നമ്മൾ അതിനെ ചേമ്പിന്റെ ഇല എന്നൊക്കെ പറയും. ചേമ്പിന്റെ ഇലേന്റെ മേലെ വെള്ളം നിർത്തുകയാണെങ്കിൽ ആ വെള്ളം എങ്ങനെയാ നിൽക്കുക? ഡ്രോപ്ലെറ്റിന്റെ രൂപത്തിൽ ഇങ്ങനെ നിൽക്കും. Have you seen it? Can you just correlate with cozy force and adhesive force? നമ്മൾ സാധാരണ ഇലയുടെ മേലേക്ക് വെള്ളം വെച്ചിട്ടുണ്ടെങ്കിൽ വെള്ളം ഇങ്ങനെ ഡ്രോപ്ലെറ്റിന്റെ രൂപത്തിൽ നിൽക്കൂല. പക്ഷേ ചേമ്പിന്റെ ഇലേന്റെ മേലേക്ക് വെള്ളം വെച്ചിട്ടുണ്ടെങ്കിൽ അതിങ്ങനെ ഈ ഡ്രോപ്ലെറ്റിന്റെ രൂപത്തിൽ നിൽക്കും. Can you just correlate with cozy force and adhesive force? What's happening in that leaf?
Very high cohesive force.
Yes, actually, cozy force is an internal matter of water. Adhesive force is a matter with leaf also. Actually, leaf cozy force ne കൂട്ടല്ല ചെയ്യുന്നത്, adhesive force ne കുറയ്ക്കുക ചെയ്യുന്നത്. Are you getting my point? ആ ലീഫിന് adhesive force വളരെ കുറവായിരിക്കും. അതുകൊണ്ട് cozy force കൂടും, അല്ലേ? adhesive force കുറയുന്നതിനോണ്ട് cozy force കൂടി. That's the reason why it is lying as droplets. Why is it acquiring the shape of a sphere? It is because of surface tension. If the cozy force is much greater, what happens is the molecules which are lying on the surface will have a tendency to move towards the place where there is no net force. Therefore, all the molecules which are lying over the surface of the liquid in that situation will try to move towards the place where there is no net force, that is towards the center. As a result, it can take spherical shape. And if you are dropping some mercury over the table also the mercury will lie in a spherical shape. Have you seen it? since Mercury is having a large cohesive force, and due to the surface tension phenomena, it is lying in the spherical shape. But if you're taking a larger drop of mercury, it will be in an oval shape. Have you experienced it? Taking a larger drop of mercury, it will be in oval shape. Can you correlate with gravity and surface tension? Can you say why a smaller mercury drop is exactly spherical in shape and a larger mercury drop is in an oval shape? Are you able to hear me? Just give it a try. Why is smaller mercury drop exactly in a spherical shape and a larger mercury drop approximately in an oval shape? Yes, you can
Small
reach
surface
out.
area.
Yeah.
Small surface area.
Can you just say it in terms of mass? It has to make smaller surface area. That's the reason why it is trying to be in a spherical shape. But the larger mercury drop, it's not actually in a spherical shape. It has taken an oval shape. Which is having more mass, smaller one or larger one?
Larger one.
Larger one is having a greater mass. Larger one is having a greater mass means it will experience a greater gravitational force. Okay. Assume that we are having a football which is not having a very high pressure of gas. നമ്മൾ അധികം കാറ്റില്ലാത്ത ഒരു ഫുട്ബോളിന്റെ മേലെ നമ്മൾ ചവിട്ടിയിട്ടുണ്ട് എന്ത് ചെയ്യും? കാറ്റ് കുറച്ച് കുറവുള്ള ഒരു ഫുട്ബോളിന്റെ മേലെ ചവിട്ടിയിട്ടുണ്ടെങ്കിൽ അത് എക്സാക്ട് സ്പെറിക്കൽ ആയിട്ടാണോ നിൽക്കുക? അല്ല. അതേമാതിരി തന്നെ ഇവിടെ എന്ത് ചെയ്യുന്നറിഞ്ഞാല് സിൻസ് ദ മാസ് ഇസ് വെരി സ്മോൾ, ദ ഗ്രാവിറ്റി ഈസ് ഹാവിംഗ് ലെസ് എഫക്ട്. That's the reason why it can acquire exactly spherical shape or almost spherical shape. But as the mass is increasing, the gravity will have an effect. The surface tension will try to make it spherical, but gravity will try to pull it down. That's the reason why it is taking an oval shape. And in the ponds and all during rainy season, that is in this season, you might have seen some insects which are floating over the water. Have you seen some insects floating over the water? We used to call it as earthachin. It will be having large legs and the leg will have a flat region like this. Have you seen that insect? If you didn't see
Sure.
that insect, you can move out and you could see that insect in the water in this season. It's actually floating over the water. It's floating over the water. Is it due to buoyancy or due to surface tension?
Surface tension.
It's actually due to surface tension. What's happening over here is, since it is having very long legs and the legs are having a flat portion over here, it is using surface tension to be over the surface of the water. Okay, is that clear? In Discovery Channel and all, you might have seen a lizard who's having a nickname which is called as Jesus Christ lizard. Jesus Christ lizard. The peculiarity of that lizard is, if it is chased by some predators, it could even run over the water. It could even run over the water. What that lizard is doing is, its claws will be very flat. It will be very flat and it can strike over the water with a large force. Then it will strike with its large palm with a very large force. Therefore, the surface tension will give a large reaction force. By using that reaction force, it's able to make the next step and thus it could run over the water. Is that clear? If you are searching in Discovery Channel or some YouTube and all, you might have, or you will see Have anyone seen that type of lizard?
Yes, sir.
Yes. Then that all are some examples for surface tension. Now, since our time is about to exceed, yeah.
Sir, a cohesive force suspension കൂടുമോ?
കോസി ഫോഴ്സ് കൂടുന്നതനുസരിച്ച് സർഫസ് ടെൻഷൻ കൂടും. കാരണം കോസി ഫോഴ്സ് കൂടുന്നതനുസരിച്ച് നെറ്റ് ഡൗൺവേർഡ് ഫോഴ്സ് കൂടും. അപ്പം ഫോഴ്സ് പെർ യൂണിറ്റ് ലെങ്ത് കൂടും. അതിനോട് സർഫസ് ടെൻഷൻ കൂടും. അതുകൊണ്ട് അതിന് സ്പെറിക്കൽ ഷേപ്പിൽ നിൽക്കാൻ കൂടുതൽ ടെൻഡൻസി ഉണ്ടാവും. That's the reason why Mercury is in that spherical shape over all the surface. ചേമ്പിന്റെ ഇലയിലാണെങ്കിലും മേശന്റെ മേലെയൊക്കെ ആണെങ്കിലും അധിക സ്ഥലത്താണ് മെർക്കുറി സ്റ്റിക്ക് ചെയ്യാണ്ട് നിൽക്കുന്നത്. അതുകൊണ്ടാണ് മെർക്കുറിക്ക് കോസി ഫോഴ്സ് ഭയങ്കര കൂടുതലാണ്. ഡെൻസിറ്റി ഒരു ഫാക്ടർ ആണ്, പക്ഷെ വേറെയും കുറെ ഫാക്ടേഴ്സ് ഉണ്ട് കോസി ഫോഴ്സിന്. അത് അതിന്റെ ഇന്റേണൽ കാര്യങ്ങൾ നമുക്ക് എന്ത് ചെയ്യുന്നാൽ അതിന്റെ മോളിക്കുലർ സ്ട്രക്ചർ ഒക്കെ നോക്കേണ്ടി വരും. അതുകൊണ്ട് അത് നമ്മളുടെ സിലബസിന്റെ ഉള്ളിലല്ല, ഫിസിക്സിന്റെ ഉള്ളിലും വരുന്നതായിരിക്കും ചിലപ്പോൾ. ഡെൻസിറ്റി ഒരു ഫാക്ടർ ആണ്. Okay. Therefore, we'll have a break, and after 10 minutes, you can rejoin in the same link when I am asking you to. Okay.